let's do a quick review on solving for x. Now, solving for x is, I want to say, like the basis of algebra. A lot of what we're going to do for the rest of the semester will involve x in some way and trying to figure out what x is. So let's start with just some very basic examples of this. When we're solving for x, it's basically because we have an equation where we know the answer and we know part of the problem, but we don't know all of the problem. And so we need to figure out what x, or the unknown part of the problem, is. If we look at example 1, it's pretty simple. We can just look at 5 plus x equals 10. Well, we know that the eventual answer needs to be 10, and we know that we have 5. So what does that make x? We can do this a couple of ways. We could test several different x's. Let's say if we wanted to test x equals 3, or we could test x equals -2. And if we were to replace x in this equation with any of those numbers, it would be 5 plus 3, if we use this one, bloop. Does that equal 10? Question mark. Well, 5 plus 3 is 8. That does not equal 10. And so, obviously, x does not equal 3. So, we know that x does not equal 3. And if we did the same thing with x equals -2, if we put -2 in here, 5 plus -2, well, that's 5 minus 2, which is 3. 3 does not equal 10, so x can't be -2 either. So what does x have to be in order for the answer to be 10? Well, because we're all pretty good at math, we know that 5 plus 5 equals 10. So in this case, x equals 10, and that's a pretty simple problem. But if the problems get too much more complicated than that, sometimes it can be a little difficult to just do the math off the top of our head. Sorry, I did that totally wrong. I'm trying to talk and write at the same time. X equals 5. So one way that we can solve this, instead of just having to know or figure out the answer, is through algebra. So when we have 5 plus x equals 10, one way we can solve this is just a very simple algebra technique, which is called adding or subtracting across the equal sign. And what this is we can basically move terms over and back over the equal sign as much as we want to. We just have to follow one simple rule. And that rule is that whatever we do on this side of the equation, this side or the left side of the equal sign, we must do on the right side. So we have to mirror. My calculus teacher liked to call this rearranging the furniture. He's like, you got to get all of the proper furniture in the right spot so that you can deal with the other furniture. So let's rearrange this furniture. In order to get 5 across the equal sign, so we just have x on one side, well, in order to get, we essentially want to make 5 zero out on this side. Well, how do we get 5 to 0? Well, we subtract 5. 5 minus 5 is 0. And remember, whatever we do on this side of the equal sign, we have to do on the other. Otherwise, we're not staying true to math. So we have to subtract 5 from the other side. So that means that 5 minus 5 is 0 plus x equals 10 minus 5. Well, that means x equals 10 minus 5 is 5. And that's how we can solve this equation for x. Okay, so looking at problem 2. We're just going to do it the algebraic way this time, even though you could probably figure out what the answer is. But let's just do it the algebra way. X minus 7 equals -3. Well, once again, we want to get x all by itself. That's what it means solving for x. X all by itself, so we know what it equals. How do we get rid of this -7? Well, in this case, we would add 7, because -7 plus +7 equals 0. But remember, whatever we do on the left side, we have to do on the right side, so we're going to add 7 over here. So that gives us, well, x minus 7 plus 7 equals 0. X plus 0. -3 plus 7, which equals 4. So for this answer to be correct, x must equal 4. And if we were to look at this and try and figure out what number take away 7 would be -3, the answer would be 4. Okay, so as you can see, pretty simple. But now we get into multiplication. Now what do we do when we have two numbers multiplied over an equal sign? Well, let's look at it. 2x equals 12. This is basically 2 times whatever x is will equal 12. Well, we know the answer to that. 2 times 6 equals 12. So we could just figure out that way and be like, well, duh, x equals 6. But in case these were harder numbers to deal with, like let's say it was 37, this equals 37. Well, now we aren't entirely sure what 2 times what equals 37. So the other way we could figure this out is to divide across the equal sign, because if we're multiplying here, then the opposite of multiplication is division. So if we divide this by 2, 2 divided by 2 is 1, and then we would just have 1x, or we could just write it as x. Those would equal the same thing. Well, whatever we do on the left side, we have to do on the right side, so we're going to divide this by 2. What is 12 divided by 2? 6. So 1x equals 6, or we could just say x equals 6. So we know that's the right answer because it matched what we already know about math. So x equals 6 for problem 3. Alright, and then the final one. Alright, so we're looking at 20 over x equals -2. This is looking like a fraction. What does x have to be in order for 20 divided by x to equal -2? Well, in the one above, we had some multiplication and we divided to solve the answer. In this case, we're going to do a little bit of multiplication. So let's write it back over here because sometimes it's easier to have more space. 20 divided by x equals -2. In order to solve this one, we're going to have to do some slightly fancy footwork, but not too fancy. Because we have x on the bottom. The x is our divider. So in order to get him kind of up on top of this, instead of being the denominator, we need to do a little bit of work. So we're going to multiply this by x over 1. And whatever we do on the left side, we have to do on the right side, so we're going to multiply that by x over 1. Now this gets a little funky. This is a multiplication x instead of another x. That's why in algebra sometimes they'll use a dot to represent multiplication so that we don't get the x's confused. But anyway, this is -2 times x over 1 and 20 times x over 1. And what does that get us? Well, if we have 20 times x, that means we have 20x over 1 times x, 1x. Okay, that's one side of the equation. And then we have -2 times x over 1. Ah, it's not moving like I want it. There we go. Alright. Well, when we have x and x divided by x, whatever x is, anything divided by itself is just 1. So we can kind of just get rid of this x. We're like, it cancels out with the x below it, so we're left with 20 over 1, and anything divided by 1 is just itself. You know, we have one group of 20, so that means we just still have 20 things. So 20 equals, anything divided by 1 is still itself, so we'll just get rid of the bottom of that and have -2x. So looking at this problem, now it looks a lot like the one we solved in problem 3. A lot like it. The only difference is that this is a negative. So to solve this, we'll just do what we did in problem 3, and we'll divide both sides of the equation by whatever will make it so x is all by itself, in this case -2. -2 divided by -2 is of course just 1x. 20 divided by -2 is -10. So 1x equals -10, and that's our answer. If you were to have looked at problem 4 and just tried to solve it using math, you would have known that 20 divided by something to equal -2 would have to be 10. 20 divided by 10 is 2, and then negative 10 because our answer was negative 2. So yeah, we could have looked at any of these problems and probably solved them in our head, but it's good to practice the algebra. All right, I'll see you in the next video.